In this video, we are discussing the 15th numerical from the exercise for the chapter Laws of Motion, which is the fourth chapter for 11th standard physics. Now, for convenience, it's better if we understand this question using a diagram. So, हम diagram और question दोनों simultaneously understand करेंगे. सबसे पहले हमें बताया गया है कि we have a ladder which is resting between a vertical wall and a horizontal ground. ठीक है, सो हमारे डायग्राम में लैडर इज रिप्रेजेंटेड बिटवीन is represented by a black line between points D and C, and as you can see this line is resting along a vertical wall and a horizontal floor. Now in the second statement हमें जो है wall और floor के nature के बारे में बताया गया है. So हमें बताया गया है कि wall is smooth. This is just an indication that vertical direction में कोई भी frictional forces नहीं लगेंगे. But on the other hand हमें बताया गया है कि our floor is rough, because of which at point C our ladder will experience a frictional force due to floor, let's call it F, to resist the motion of ladder in the positive x direction, that is in this direction. Now after this हमें जो है एक statement दिया गया है using which we can actually derive the condition to calculate the magnitude of this force, which we will use or see later in this video. And after this comes the interesting part of this numerical is the entry of a monkey. So हमें बताया गया है कि now comes a monkey, and then this monkey decides to climb on this ladder setup, and it climbs the ladder till it reaches, let's say, some point A, and beyond which if the monkey climbs any further it will introduce counterclockwise torque, unbalanced counterclockwise torque along the axis point C, such that this entire ladder will then topple down. So that's not what we want. So basically there's a distance, there's a maximum distance till which this monkey can climb, and that distance is supposed to be what we are required to find. So we are required to find how far the monkey can climb the ladder. And we also have a second quantity which is needed to be found. So as I said, the ladder is resting on the wall at point D. So at this point, this wall might exert a horizontal reaction HW on this ladder, and that horizontal reaction is also what we are supposed to calculate. So we are supposed to calculate a distance which is AC from the diagram, and then we are supposed to calculate the value of a force which is HW from the diagram. Now let us see what sort of given data it's been given to us to calculate these two values. सबसे पहले हमें जो है ladder की length दी गई है जो हमारे diagram में DC represent करता है, that is 2 meters. Then we have been given the mass of our ladder. So mass of the ladder is 10 kgs. So the weight exerted by the ladder would be 100 newtons because weight is equal to mg. और यहाँ पे g को हम 10 consider कर रहे हैं simplicity के लिए. So we are interested in weight offered by the ladder, that is 100 newtons. Then हमें दी गई है कि distance between the base of the ladder and the vertical wall. So basically distance between point C and E is given to us as 1.2 meters. इसके बाद हमें जो है monkey का mass दिया गया है which is said to be 20 kgs. So because of which monkey is capable of exerting a weight of 200 newtons. As always, weight is equal to mg, where this time weight mass is of monkey. एंड देन जैसे कि मैंने बोला था फ्रिक्शन और नॉर्मल रिएक्शन के बीच में एक रिलेशन दी गई है. सो द टोटल नॉर्मल रिएक्शन एक्सपीरियंस्ड बाय दिस लैडर, इफ वी डिवाइड इट बाय 2, the value of friction is supposed to be equal to that. Now that we have written all our given data and we have understood the diagram, let us proceed to solve this numerical. So we have to calculate two things: distance AC and force HW. So let's start with the first section of our solution. Before we get into finding out the actual distance, there are certain values which we need to figure out first in order to calculate the desired quantities. सबसे पहले let us consider this triangle. Now this triangle is represents this situation minus all the force components. We are just focused on the distances which are at play at this moment. So हम जो है consider करेंगे only the distances. So यहाँ पर हमें length of ladder, that is DC, is given to us 2 meters, and the separation between ladder and the wall is given to us as 1.2 meters. That is the length between points C and E. And if we were to apply Pythagoras theorem to this large right angle triangle CDE, I can say DC square is equal to C square plus ED square. इसके अंदर DC और CE का वैल्यू हमें गिवन है, but ED is unknown. So let's find ED from this particular equation, and if we were to substitute the values, हमें ED की वैल्यू आती है as 1.6 meters. ठीक है, and why not? Because as you can see, all these values are Pythagorean triplets, that is 16, 12 and 20. इसके बाद we need one more value before we proceed. We need to find this distance. We need to find the distance between CB dash. But before we do that, we need to establish one fact that कि हमारा जो larger triangle है CDE is similar to our smaller triangle CBB dash, and as you can see, it is similar. So based on that, the ratios of the side should be equal. So if I were to calculate the ratio of side CB is to CD, and then is to calculate another ratio of side CB dash is to CE dash, I would find both those ratios to be equal, as both the triangles are similar. So I can say CB upon CD is equal to CB dash upon CE. Now from this diagram, B is the center of mass of the ladder. So I can say that this distance CB must be half of the distance of CD. So CB is just half of CD. And if I were to further solve this equation, I would get CB dash as 1.2 divided by 2. And if I were to calculate the value for CB dash is equal to 0.6 meters. Why is this is the distance which we wanted to calculate? Because this is where the moment of force due to the weight of ladder would act along C. So that's why we wanted CB dash as a distance. Now let us move further to calculate some forces that are in play, because हमें finally torque के basis पर solving करनी पड़ेगी. So torque के लिए we need distances and force. So if we were to draw the FBD of the ladder, it would be something like this, where we have a normal in the vertically upward direction and the two weights. One is the weight due to ladder and the other is the weight due to monkey acting in the downward direction. And then we have only two forces in the horizontal direction. One is the frictional force due to ground and other is the reaction of wall. So they must balance each other out, because linearly हमारी ladder move नहीं कर रही है. So I can say for vertical forces, normal reaction must balance both these weights. So हमें दोनों weights की values पता है. If we were to calculate, यहाँ से हमें मिलता है normal reaction to be 300 newtons. Now horizontally अगर हम देखें, तो F must be equal to our frictional force must balance our horizontal reaction force. So, but we know that F is equal to half of normal n by 2. This is the given condition. So on this basis, our horizontal reaction must be n by 2, because it is equal to F and F is equal to n by 2. So I can say our horizontal reaction force offered by wall is 300 by 2, which is 150 Newton. So look at this. What we have done is we have solved the second quantity which was required by us first, because that was in our flow. So सबसे पहले हमने क्या किया है, horizontal force की value ढूंढ ली है, horizontal reaction, that is 150 Newton. So half of the numerical is done. Now let us quickly see the distance, that is the max distance. So for this we need to understand the concept of moment of force. तो हमने देखा है कि whatever rotation is possible, that rotation it has to happen along our axis point C. So अगर हम उसके अराउंड सारे एजेंट्स को रिजॉल्व कर दें, these are the agents that can cause torque around C. So हमें कुछ ऐसा डायग्राम मिलेगा. हमारे जो दोनों weights है, that's weight of monkey and ladder, both these weights want this ladder to rotate in counterclockwise direction at point C. And so does our frictional force. It wants the ladder to rotate in counterclockwise around C. But the horizontal reaction offered by the wall wants the ladder to rotate in the clockwise direction. So I can say that torque due to this particular component should balance out the resultant torque due to all of this component. हम लेफ्ट साइड पर सारे एजेंट्स जो काउंटर क्लॉकवाइज टॉर्क कॉज कर रहे हैं उनको लिखेंगे, एंड राइट साइड पे टू बैलेंस इट आउट हम उस एजेंट को लिखेंगे विच इज कॉजिंग द क्लॉकवाइज टॉर्क. So if we were to substitute the values that are known to us except for this value, because that's what we are trying to calculate. So if we were to substitute the value, so हमें weight of monkey पता है, that is 200. हमें CA dash अब भी पता नहीं है, so we keep it unknown. हमें weight of ladder पता है, हमें distance between point C and B dash पता है, just calculate किया. Then हमें horizontal reaction का value पता है, and then हमें distance between point E and D पता है 1.6. In this case, हमारा जो frictional force लग रहा है, that is acting on the axis point. So distance between frictional force and axis point is 0. So ये term जो है पूरा 0 हो जाता है. And if we were to substitute all these values and further simplify the equation, we would get CA dash, which is the distance we are trying to calculate, is equal to 180 by 200. And if we were to further solve it, we would get CA dash as 0.9 meters. Now let this be our fifth equation. And now let us see what exactly is CA dash. Well, CA dash is the distance between the base of the ladder and the point where the vertical weight of monkey is acting. But we don't want this distance. We want distance AC, that is a distance that was traveled by the monkey. So again, looking at this triangle, I can say that this larger triangle CDE is similar to this smaller triangle CAA dash. Okay, so they are similar. So because of this, I can say that the ratios of their length must be equal. So if I were to calculate the ratio of CD is to CA, it must be equal to the ratio of CE is to CA dash. And the only unknown term over here is the CA, which is the distance which was traveled by the monkey. So if I were to substitute the values and solve the equation, I would get CA as 1.5 meters. So this is the actual distance which our monkey climbs along the ladder, that is 1.5 meters. And the value of the horizontal reaction offered by the wall was 150 newtons, as we had calculated it long back over here. With this, we are done with this particular numerical. I hope this was helpful to you. This PDF of the solution is present in the description, so do check it out. Thank you.